communication technology. So the first 1 hour and one and a half hours, I'm going to talk about the history of cellular networks and belong, etc. Okay, so already your HOD summarized most of them, but I will give you a little bit more detail. Okay, so this is the course schedule. As I said, the first hour I will talk about the history of a cellular network, and then after lunch we will start looking at wireless channel models and diversity techniques and MIMO techniques and massive MIMO, etc., which is going to be tomorrow. Then we will talk about some belong 5G technologies like a full duplex radios and distributed learning, etc. In the afternoon, we will, in the last session of the days, we will do some tutorial questions and the lab, simulations, etc. So that's the plan. We can change according to your wish as well. So what is 5G? So, the mobile communication started in early 80s. Sorry. Yeah, that's it. Started in early 80s. The standard is called AMS in North America, and Total Access Communication System, one of the standard in UK. So this first generation cellular network is analog communication system. So our voice is modulated to carrier frequencies and transmitted through the air. Okay, there's no analog to digital conversion or anything. So our voice is directly modulated to the carrier frequency and transmitted through the channel via FM system. So this is mainly for the voice communication. Okay. And then this is started, as I said, early 80s. And then early 1990s, the second generation of cellular network happened. And the standard is called GSM, mainly developed in Europe. And this is actually a narrowband system. The data rate, it can support up to 80 to 100 kilobits per second. So the second generation is a digital technology based on TDMA technology, and it also can support text messages, etc. Then 3G introduced in early 2000. The standard is UMTS and it's again a digital technology. After second generation, everything is digital technology. Okay, so this is the kind of a broadband system up to 2 megabits per second data rate it will support. Not only it can also support wireless internets and video calls and mobile TV as well. So, the broadband is first mobile broadband is first introduced in 3G system in early 2000. Then 4G is introduced in 2010. This is is a true mobile broadband system. When people designing 4G system, what is the objective is to, if you are in the home, you are connected with your desktop computer via DSL via connection. The experience that you enjoy by downloading and uploading the files, the fast downloading and uploading services, that kind of experience you want, these industries and academic wanted to give you in the mobile devices. So that is the objective when people designing a 4G system. So The 4G system is the data rate is like a DSL-like experience. 1 hour HD movie can be uploaded or downloaded in 6 minutes. Okay, so that's the objective when people designing 4G system. So 4G system can support apart from mobile broadband, video calls, and mobile TV, and gaming and cloud computing, etc., also supported in 4G technology. Then, 5G is started in the research is started around 2012, etc., and deployed in 2018 and 2020 onwards. The 5G base stations are deployed. The objective when industries and academia are designing 5G system, the objective is to, if you are in the home, your desktop computer is connected through the fiber link, the experience that you enjoy by the speed, data rates, etc. That kind of a data rate we wanted to give you in the mobile device. So that is the objective when people designing the 5G system. So it's like a fiber-like experience in your mobile device. So that's the objective. So 5G can, apart from gaming, etc., it is also give you different services like your HOD said, enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communication. So it is the not only voice, it can support many things as well, and it will also lead to support different verticals, industries like transportation and manufacturing, healthcare, etc. So, so the 5G is the true broadband and service, and it also provide more than that as well. So 1 hour HD movie can be downloaded in 6 seconds. In 4G, it is 6 minutes. You can see it's a 1 hour HD movie is downloaded in 6 minutes, but in 5G, it can download it in 6 seconds. So it's an order of magnitude performance improvement in the 5G system. So this is the spider diagram. So you can see that this area, the light shaded area is the 4G technology, and the dark shaded area is the 5G technology. You can see the peak data rate 4G is giving around around 1 gigabits per second, but 5G is going to give 10 gigabits per second. The cell edge data rate is like a 10 megabits per second, but 5G can provide 1 gigabits per second. The spectral efficiency is enhanced as well, and mobility is also enhanced compared to 4G, and the energy cost efficiency also enhanced. Another important thing is the latency. So 5G, the latency become a 1 millisecond latency, and 4G is like 100 millisecond latency. So this latency is very important to support the future, ultra reliable latency communication and autonomous driving, etc., or industrial IoT, etc., to support those kind of controlling the, remotely controlling the industrial equipment. We need a lower latency communication. So that's why the 5G is able to support this industrial IoT application. So what 5G is, what are the 5G important technology that will give you this kind of a key performance index is there are 3 things that people come up with. One is spectral efficiency is enhanced by using massive MIMO technology. So there are 3 areas the 5G enhance the services compared to 4G. One is called spectral efficiency. It's enhanced by mobile broadband. The second is the spectrum extension. So the 5G is the one first introduced millimeter wave communication. So up to 4G, we were using, gigabits per second, gigahertz frequencies, like a FR1, they call FR1, frequency range 1 up to 7.125 gigahertz. But 5G is the one first introduced millimeter wave frequency. By extending spectrum, you will be able to provide more data rates, okay? So there are three dimensions the 5G improved. One is spectral efficiency, second is spectrum extension. The third is the network densification. So what is network densification is bring the base station closer to the user. If you bring the base station closer to the user, then the user will enjoy high signal-to-noise ratio, then that will provide high data rate. So these are the three dimension 5G improved compared to 4G. Okay, the 4G capacity is like this small box here, but the 5G the enhancement is the big cube here, okay? The spectral efficiency is increased by using massive MIMO. So the massive MIMO mean in the 4G base stations, only 4 or 8 antennas is used, but in the 5G base station, 64 antennas or 128 antennas or 256 antennas. If you are using a millimeter wave frequency, it can go up to 512 antennas, etc. So by using large number of antennas, you will be able to provide a very, very narrow pencil beam to each of the users. Then that will enhance the signal to interference plus noise ratio. By doing so, you will get the high spectral efficiency. So these are the kind of a three-dimension people have did research and enhanced the 5G services. So I have worked on all three dimensions as well. My projects, European project and UK funded project called HARP and etc. We worked on massive MIMO technology and distributed MIMO technologies as well. And the CRONE and the ADAL projects are how to use the spectrum efficiently, license shared access, etc. These are the two projects that I work on this domain. Again, the HIATUS and HARP project are how when you do a cell densification, you will be need to handle the interference properly. There is a technology called interference alignment. We have studied those things in the cell densification domain as well. So how to handle interference effectively. So I work on all three dimensions in my previous research. So beyond 5G, we see the AI will going to play a big role in beyond 5G domain. Ultra reliable low latency is going to be enhanced further, and we like to see 0.1 millisecond latency. 5G is giving 1 millisecond. We like to see 0.1 millisecond latencies, and massive machine-to-machine communication is now giving you 10 devices are connected with 1 meter squared. This will be further enhanced in this below 5G domain as well. We like to see 1 terabits per second data rate as well in the future as well. So this is the objective for the future wireless communication, and we will see 5G advance is currently happening, and this will be deployed in 2024 to 2028, and from 2028 the 6G deployment will be going to happen as well. So that's the kind of expectation, and AI will be playing a major role by orchestrating all these 5G, below 5G networks. So what do we have in 5G? As I said, there are three major scenarios: enhanced mobile broadband, massive machine-to-machine communication. 1 million devices are connected in 1 kilometer per square areas, ultra-reliable low-latency communication with 1 millisecond delays, etc. The key technologies are, as I said, massive MIMO, millimeter wave communication, and ultra-dense networks. So these are the three key technology introduced in 5G compared to 4G to support these scenarios. So why do we need a 6G? Okay, so that's the question we need to ask. So 5G is already providing a good quality of service. Why do we need a 6G? So, 5G will not meet all the requirement in 2030. Application of 3D videos or virtual realities or augmented realities require terabits per hertz data rate. So while 5G can only provide gigabits per second. So in order to support virtual reality and augmented reality, etc., we need a terabits per second data rate. So that's why we need a 6G. So moreover, application of autonomous driving, industrial IoT require much less latency, like 0.1 millisecond. So by 5G is giving you only 1 millisecond latency. So that's another reason that we need a 6G. And another important thing is the global coverage, okay? So we need 100% coverage of our Earth. So for 6G, need to provide a nearly 100% coverage through the space. Space here is a satellite communication network. AR mean here is UAV will be supporting hotspot areas or unconnected areas will be supported by the UAVs. And ground, this is our terrestrial network, current cellular network, and maritime is a sea network. So by integrating all of these satellite and UAVs and the current terrestrial network and maritime networks, we will be able to provide a total 100% coverage to our Earth. So that's one of the goal in 6G. So 6G, there are two study item is happening in 3GPP. I'll tell you in a minute about those things. So, and then we also like to have a very accurate localization as well, okay? Sub-centimeter localization accuracy to support robotics and industrial IoT application. So that is also very accurate localization is not there in 5G. So we need a 6G to give you very, very accurate localization. Okay, so with the big data set, a diverse scenario, new service requirement, 6G will enable a new range of intelligent application with help of AI and ML. Okay, and so we can see 6G will see a conversion of communication and computing, control and localization and sensing as well. Sensing is one of the important thing which is called integrated sensing and communication. So then the future base station not only communicate but also sense the environment and track the users. By doing so, they can beamform accurately and provide a high signal to interference plus noise ratio. So sensing and integration is very important thing as well. So, there is a IMT, International Mobile Telecommunication Organization. This is the organization defining the requirement for 5G and 6G, etc. So IMT 2020 defined the 5G requirement. Now IMT 2030 defined the 6G requirement. Okay, so as I mentioned in IMT 2020, there are three services I mentioned: enhanced mobile broadband, massive machine type communication, and ultra reliable low latency. These are now enhanced in the 6G which is called, the enhanced mobile broadband is called now, in 6G is called immersive communication. Ultra reliable low latency is enhanced, that version is called hyper reliable and low latency communication. And massive mesenteric communication is enhanced version in the 6G is called massive communication. Apart from these three services, 6G is going to give you 3 more services that is called AI and communication, ubiquity, connectivities, and integrated sensing and communication. So this is the very, very hot topic nowadays, integrated and sensing communication. As I said, the future base station not only communicate, they also going to sense the environment, okay? So 6G, there are, as I seen here, there are 6 services, okay? Immersive communication, that's the enhanced mobile broadband version of the 5G. And hyper reliable low latency communication, this is the enhanced version of the ultra reliable low latency of the 5G system. And ubiquity, connectivity, massive communication, and integrated communication. So, so all these will be designed in 6G with the, with the objective of sustainability, connecting with unconnected. Connecting with unconnected mean whatever is not connected in the 5G will be connected in 6G. So that's what is connecting the unconnected. 6G will connect everything. And security is also another important design objective for the 6G as well. So, so here, the user scenarios here, you can see these green shaded areas are enhanced version of the IMT 2020, and this blue one is the new capabilities, okay? The position accuracies and sensing accuracies, etc. The new KPI in the 6G scenarios, okay? So these are the 5G KPIs are enhanced. You can see latency is reduced to 0.1 millisecond, reliability is reduced to 10 to the minus 7, security, etc., the mobility, etc. These are the 5G KPIs are enhanced in the 6G, and some new capabilities are introduced as well. So this IMT, as I said, IMT 2030 is the one, define the requirement for the 6G, okay? So this is just to summarize what I said. The peak data rate for 6G will be terabits per second. Connection density is 1 million device in the 1 kilometer per square. Latency is 0.1 millisecond. Energy efficiency, everything will be, we like to see an order of magnitude enhancement, okay? Spectral efficiency and localization as well. Okay, so enabling technology, I think these are some of the enabling technology. There will be more as well. We need to manage the spectrum very efficiently also as well. So dynamic and intelligent spectrum sharing controlled by AI. This is AI can play a big role, hopefully, in the 6G to manage this scarce spectrum resources. So that's one thing people are working nowadays. And enhanced spectral efficiency, like a self-free massive MIMO. So the user will be not only served by one base station, many access points will be serving one user, and the cell boundaries are eliminated. This is called self-free massive MIMO. And IRS is also another intelligent reflected surface. This is also another research, hot research area nowadays. What is this is doing is by deploying the intelligent reflected surface in the environment, you can tune the environment such that the spectral efficiency of the user can be, or the coverage of the user can be enhanced. So here the IRS will be tuning the environment such that the spectral efficiency is enhanced. And UAVs, as I said, to deploy to give a coverage. Hopefully this blockchain, some more smart contract, these are one of the technology introduced by blockchain. This is maybe needed to give a spectrum on the fly. So smart contract using blockchain may be another interesting topic for dynamic spectrum allocation. So network architecture, SDN and NF, network function virtuality, this is research also need to be enhanced in the 6G as well, and cloud and edge computing also will be enhanced in the 6G scenarios. So summary of new paradigm shift, as I said, space, air, ground, sea integrated network, all spectra integrated network. So FR1 here is a called frequency range 1. This is up to 7.1 gigahertz, and FR2 is starting from 24 to 52 gigahertz. This is FR2 frequency range 2. I will show you a little bit more about this frequency range later on. Okay. So, so security in the 6G also enhanced as well. So next half an hour, I would like to talk about 3GPP. So 3GPP is the organization introduced in 3G era in 1990s onwards. Okay, so this is the organization defining the standard. Okay, but you know, they put the name 3GPP in 3G era. They never changed the name after that. Still keeping the 3GPP name. So, but they are the one defining the standard for after 3G as well, 4G, 5G, etc. So, so they 2.5 years, they do a new release. This is called a release. So that will defining the standard. Okay, with the, what is the base station requirements, what is the service requirement, etc. Defining this 3GPP release. Okay, so release 8 is introduced is the one introduced 4G, and release 15 introduced 5G. And currently 3GPP is working on release 19. They recently completed release 18. So there is already a 4 release in 5G is happened. Okay, release 15 is a 5G introduced. Release 16 is one of the enhancement, and release 17 and release 18 is recently frozen. So these are the they all kind of 5G releases. We expect to see release 21 will be the 6G standard. Okay, so these are the releases. So let's see what these releases introduce, etc. So here, as you can see, 5G is introduced in release 15, which is in frozen in 2019. Then after that, release 16, release 17. Now recently release 18 is completed in 2024. So you can see in release 15, they focus mainly on enhanced mobile broadband, which is a standard, the 5G standard called 5G NR, new radio, and the frequency range is sub 7 gigahertz, as I said, up to 7.125 gigahertz frequency range 1, and 5G is the one first introduced millimeter wave frequency as well. And the 5G also introduced a scalable numerologies. What does numerology mean? The 5G technology is based on OFDM system. So OFDM in 4G, the subcarrier spacing of the OFDM is fixed to 15 kilohertz only. But in 5G, the subcarrier spacing is changeable. So it can be 50 or 30 or 60. It can go like this. So it's called numerology in 5G. So the flexible numerology is introduced in 5G. And basic ultra reliable low latency also supported in release 15. Then release 16, what are the new features in release 16? is unlicensed spectrum, is how to handle unlicensed spectrum. This is called NRU, New Radio Unlicensed. Release 16 also introduced enhanced ultra reliable low latency communication as well. So the release 15 is the first 5G deployment is basically enhanced mobile broadband service. Okay, the ultra reliable low latency and massive communications are mentioned in 5G, but they are not fully deployed so far. So they are going to be deployed effectively, from now on until 2028. Okay, so those are basically defined in release 16 and release 17 as well. So release 17, they have, up to release 16, they consider frequency up to 52 gigahertz. But in release 17, they extend the millimeter wave frequency to up to 71 gigahertz as well. Lower complexity NR Lite. So this is what is this one is called. Your wearables are going to be connected with the base station. This is the standard called red caps. So your watch and your Google Glass, etc., may be connected to the base station. So this is called NR Lite. Okay. So those things are introduced in release 17. Okay. And release 17 also introduced two more very important studies. One is called non-terrestrial communication. This is the integrating the terrestrial and non-terrestrial network, and also another one is non-terrestrial IoT. These are the two study items introduced in release 17. Okay, improved IoTs and position accuracy and vehicle to X communication, enhanced IAB. IAB means integrated access and backhauling. So the millimeter wave frequency cannot travel very far because of the path loss, etc. So we need to introduce a kind of a relay kind of a network that's called integrated access and backhaul, which is introduced in the release 16 and release 17 as well. So the release 18 is, as I said, is frozen recently. They are mainly studying how the AI or machine learning can support the future wireless communication. That is the study item mainly focused on release 18. Okay, so this slide summarizes what I said already. So here is the 4G foundation, and this is the release 15 features. As I said, flexible numerologies and different 4G, the time slot, everything is fixed. Okay, but in 5G we introduce a mini time slot which can support ultra reliable low latency communication. So those things are introduced in 5G: mini slot, flexible numerologies, advanced coding. The Polo codes are used for the to control channel, and LDPC code and turbo codes are used for the data channel. Massive MIMO and mobile millimeter wave communication, etc., are introduced in release 15. So release 16, unlicensed spectrum, as I said, enhanced power saving mobility, high precision positioning, side link, device-to-device communication is introduced in release 16 as well, etc. So the release 17 is again the millimeter wave frequency is extended to 71 gigahertz, and reduced capability devices. These are the NR lights. Your wearable is connected to the base station, device enhancement, and there are two study items introduced in release 17 which related to non-terrestrial network. Okay, one is the integrated satellite and terrestrial network, and other one is IoT network with the satellite communication as well. So release 18 is more focused on machine learning stuff. Yeah, so as I said, more spectrum introduced in release 17, reduced capability device connection introduced, device enhancement, non-terrestrial network study item, etc. The new features in release 17. So I think that's all I would like to say at the beginning of this introductory lectures. Any questions? Yeah. 70. Which one? IRS? It is statics. Yeah. So what is happening is, if the users are not in the line of sight of the, especially in the millimeter wave communication, etc., line of sight of the base station, then the IRS can be put in the environment that the signal can be reflected and give a service. But I mean, there are a lot of research going on in the IRS, intelligent reflected surface. But some of the key players like Huawei and all these people are not, favorable to IRS technology, because by doing intelligent reflected surface and reflecting the signal to the users, maybe one user will get, few users will get benefit, but other users may get interference as well. So, so how IRS technology is going to be useful in the 6G is still questionable. Yeah. The IRS, it is frequency independent. Yeah. Yeah, 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 yeah. Any questions? Any other questions? So I think I hope I gave a brief introduction to history of cellular network and where the 6G research are going on nowadays, and there's some 3GPP activities, etc. So let me show you one more thing about the frequencies. Okay. So this is the slide. Yeah. So these are the frequencies. I mean, wireless communication, we need a frequency. The frequencies are very, very scarce resources. So you can see up to 7.125 gigahertz is called frequency range 1. Okay, so that's the frequency, is a good frequency, can travel far away, etc. But this frequency range is already crowded with different services, like the defense people are using, the air traffic control, police, and all these people are using this kind of frequency. So these frequencies for cellular service is very, very limited. Okay, so this is the good frequencies. And then 24.25 gigahertz to 52 gigahertz is called FR2, frequency range 2. This is introduced in release 16. Then in release 17, that frequency is extended to up to 71 gigahertz. Okay, so this is still frequency range 2 -1 and frequency range 2 -2. Then in between frequency, nowadays people are considering that one, that is they named the frequency range 3, which is up to 7.125 to 24 gigahertz. So this is also a good frequency range, can travel and do many things as well. So this is the frequency range 3. Now they introduce a new name. So first they introduced this one and this one, frequency range 1 and 2. Now they introduce frequency range 3 as well. And then there are more frequencies now consider up to terahertz communication as well. So, but still the challenges of higher frequencies still exist. Okay, even though the millimeter wave frequency is introduced in 5G, but the millimeter wave, the traffic of 5G through the millimeter wave is so far is very, very less, okay, like a 2 or 3% of the 5G traffic used by millimeter wave frequency. So millimeter wave frequency is, still not that much successfully deployed, okay. So there are a lot of research people are doing in terahertz, so but how successful those frequencies for wireless communication is still questionable as well. Any other question? Yeah. Yeah, sub-6, yeah. So, I mean, and LTE people call sub-6 gigahertz, but in 5G they call a frequency range 1, yeah. Yeah. FR1 is a good frequency. It can go kilometer range, etc. So that's the big microcell, etc. Supported by FR1. And the small cells, very, very small cell, can support FR2, millimeter wave frequencies. Yeah. So in the millimeter wave frequency communication, we need a large number of array antennas, like 512 antennas are used nowadays to make a very, very narrow beams. And then if the user are moving, we also need to do a beam tracking, etc. So these are, challenges for the millimeter wave communication. The blockage and all these are, obstacle for the millimeter wave success. Any other question? Okay, so this is the integrated access and backhaul I mentioned. So millimeter wave frequency cannot travel very far away. It can go up to 200 meters only. So the people use, Release 16 introduced IAB, is called integrated access and backhaul. So what is that is happening is it's like a relay nodes. G node B is the base station, or IAB donor that can give wireless backhaul to IAB node. This IAB node will give you service to the users. So it can be a one hop or it can be multi-hop as well. So this is a wireless backhaul and wireless access. So that's what is called integrated access and backhaul. So this is one of the technology which is introduced in 5G. Okay, so these connections are a wireless connection. It's not a wired connection. Yeah. So and the G node B is the base station or IAB donor. This is connected to the core network. Yeah, so yeah, there are two study items happening in the non-terrestrial, terrestrial and non-terrestrial network. One is 5GNR for non-terrestrial network,